Picture this, a farm that operates like one giant, intelligent organism. You've got swarms of robots and drones all moving in perfect harmony, sensing, communicating, and acting with reflexes that are literally faster than our own nervous system. Now, this isn't science fiction. This is the future of agriculture, and it's all going to be powered by the next massive leap in wireless tech, 6G. So let's dive in and see how this all works.
All right, so here's our game plan for this explainer. We're going to start with this whole concept of robot swarms. Then we'll get into the unbelievable speed that 6G brings to the table. From there, we'll explore how these machines actually form a hive mind, how they get superhuman senses, and finally, how it all comes together to create a farm that's truly autonomous.
Okay, so the first big thing you got to wrap your head around is a total shift in thinking. We're moving away from the idea of one single, huge automated tractor that just follows a program. The future's all about countless smaller, smarter machines that work together. Think less like a lone wolf and more like a colony of ants or a swarm of bees. But, for swarm to actually work, it needs a central nervous system, right? Something that connects every single member and allows for instant coordination. Well, that nervous system is 6G. It's the magic ingredient that transforms a bunch of individual robots into one single intelligent force. Now let's talk about what really makes this possible. And it all comes down to one thing: speed. I mean, for a whole swarm of robots to work on delicate jobs, their reflexes have to be practically instantaneous. They need to talk and react faster than a human can even notice. And this is where 6G just completely changes the game. Look, 5G did an amazing job at cutting down that delay or latency to about 1 millisecond. But for the kind of hyper-precise wireless control that advanced robotics needs, that's still a tiny bit too slow. 6G is designed to absolutely smash that barrier, making the connection so fast it basically acts like a physical wire. Less than 0.1 milliseconds. It's a crazy small number, so what does that actually mean in the real world? Well, it's the tiny, tiny difference between a robotic arm gently plucking a perfectly ripe strawberry and one that misjudges the timing by a fraction of a second and just crushes it. It lets machines actually feel what they're doing with incredible precision. And it's not just about being fast. It has to be unbelievably reliable. 6G is aiming for 7 nines of reliability, which is just a mind-boggling number. And that's not just for show. It's absolutely critical for safety. It means when you hit the emergency stop button on a massive, autonomous tractor, you know with near-perfect certainty that it's going to work every single time. All right, so we've got these super fast, super reliable robots. Awesome. But how do they go from being a bunch of individual machines to a coordinated swarm? How do they develop that collective hive mind? It all starts with how they talk to each other. The secret sauce here is a feature called in-X subnetworks, and it's a really cool idea. Basically, it lets the robots cut out the middleman. Instead of sending every little piece of information back to a central cell tower, they can form their own local pop-up networks and talk directly to each other. So here's how that would actually play out. The robots enter a field and boom, they instantly create their own little private network. A drone flying overhead might spot a patch of weeds and can literally just tell a ground rover directly, hey, go take care of the spot. The whole group just works in perfect sync, sharing jobs and data instantly without any lag. Okay, now this is where things start to feel like they're straight out of science fiction. With 6G, the communication signal itself becomes a new kind of sensor. So the robots won't just see with cameras, they're going to be able to perceive the world in ways that are totally invisible to you and me. Think about it. A camera sees what we see, right? The surface of a leaf, a bug, maybe some damage. But 6G gives these robots 2 superpowers. First, a technology called ISAC lets the signal act like radar, so it can spot an obstacle that's completely hidden behind a row of corn. And second, and this is wild, terahertz waves let it do a kind of molecular scan, checking the water content inside a plant or detecting the very first chemical signs of a disease days before we could ever see it. Now, you might be thinking, that's great, but what about farms in the middle of nowhere with no cell signal? And that's a huge problem today. 6G is being designed from the ground up to fix this by creating one giant, seamless network that combines ground towers, drones, and satellites. This makes sure the swarm has perfect connectivity everywhere, with drones even acting as mobile flying base stations to cover the most remote spots. So, let's put all these pieces together. You've got the lightning-fast reflexes, the hive-mind communication, these incredible new superhuman senses, and connectivity absolutely everywhere. When you combine all of that,
Well, that's when you finally get a truly self-sustaining, intelligent farm. And there's just one last piece to this whole puzzle, and it's a big one: power. I mean, how are you going to keep thousands of little sensors running all across a massive farm? The answer is a technology called ambient backscatter. This lets tiny, cheap sensors work without any batteries at all. They just pull the energy they need right out of the air from the radio waves that are already around them, making the whole system truly sustainable. So the great transformation is really this: we are moving from thinking about a robot as just an automated tool to seeing it as an intelligent colleague. It's no longer just a dumb machine following a program. It's a partner that can literally see invisible diseases with new kinds of waves, talk to its teammates to divide up the work, and respond to a command in less time than it takes to blink.
And this level of hyper-connected intelligence on a farm is really just the beginning. It's the proof of concept for so much more. So the final question to really think about is, if we can make a farm into a self-aware ecosystem, what's next? What happens when we apply this to our cities, to our supply chains, or even to healthcare? The possibilities are truly profound.